Hey class, we're on section 4.6 now. You've got some new notes, new note packet. They should be in Google Class at this point, along with an answer key, hopefully. Section 6 is a strange section. It might work for you, it might not, so feel free to use it or not. It's completing the square. The main purpose of completing the square is to prove that the quadratic formula is a thing and works. Which I'm not going to prove for you this year. But there might be some things in this section that you like. You may discover that you like solving things with completing the square. And if you want to do that, then feel free. On the test that I've already created, it says here are some equations, solve them however you want, whether it's factoring, completing the square, or quadratic formula. So this stuff works, so I want to present it to you and see if you like it. First of all, the first thing I have to share with you is, you know the square root of 9 is 3. That's positive only. But if you have the equation x squared equals 9, you use the square root tool to get your answer. And when you introduce the square root, you also have to introduce the plus or minus. We can see pretty easily that 3 squared is 9, but isn't negative 3 squared also 9? So again, if you have a something squared equals a number, when you solve that by using square root, you've got to include the plus or minus. Knowing that, how do I find a new? Here we go. So knowing that, if we want to solve this equation, you notice that all we have is a single x variable. We don't have an x squared and a plain x. We have to figure out what to do with them. There's just a single x there. It's squared, but we can get that by itself pretty easily. And we can do that just by maybe subtracting 5 from both sides. And we get 2x squared equals 15. Divide both sides by 2 and x squared equals 15 halves, which means when I square root both sides, I end up getting x equals plus or minus square root of 15 halves. This is not simplest form. We'll talk more about simplifying square roots in a later chapter, but for now, let's just recognize that I have two answers, a positive square root of 15 over 2 and a negative square root of 15 over 2. We'll do this one real quick over here because I think it might show it a little bit better even. If I add 3 to both sides, I get x squared equals 32. If I divide both sides by 8, I get x squared equals 4. If I square root both sides, I get plus or minus the square root of 4. Oh wait, that's just plus or minus 2. My answers are 2 and negative 2. I have both of my answers. So again, if you have just a single occurrence of the x, yay, it works out great. But sometimes we don't have that, right? Sometimes we have these things, an x squared and an x term. And yesterday or the previous days, whatever it was, we talked about needing to factor. And if you have them factored, two things multiplied together to equal 0, you know one of them has to be 0. This one isn't set equal to 0. I know we should probably subtract 9, and we could, but let me show you another way just for fun. What is the square root of 36? 6. Doubled, you get 12. That matches, which means this is going to factor nicely as x, 6, and 6, same sign, both positive. Oh wait, let's actually write that this way. We could actually go right from here to here. The square root of x squared is x, square root of 36 is 6. Now I've got something squared, a single occurrence of x. Something squared equals 9. Could I just square root both sides and find out that x plus 6 equals plus or minus 3? Subtracting 6 from both sides is going to give me x equals negative 6 plus or minus 3. That means x equals negative 6 plus 3 is negative 3. Negative 6 minus 3 is negative 9. Those are my two answers. So it's another way of working through this. Would it work to subtract 9 from both sides? Yeah, it would. And this would factor nice. But the cool thing about this completing the square idea is it doesn't have to factor in order for us to solve it. So more on that in a second. Let me scoot on down This next one, I've got to go back and find this right here. Here's our technique for completing the square. If you see a question like this, what I'm asking is, what is the number that goes right here for that really cool factoring thing to happen? And knowing that we square rooted and doubled to see if it matched, now we do the opposite. We take half of the b and then square it. What's half of 8? 4. What's 4 squared? 16. And we have a 16 right there. Over on that one, that middle term is a negative 20. What's half of negative 20? Negative 10. What's negative 10 squared? 100. And those will both factor nicely. In fact, if I wanted to factor them, it would become x 4, same sign. This would become x 10, same sign. Both of them squared. That's how the completing the square works. We're completing this binomial squared thing. Okay, cool. So let's see if we can solve these equations then. So if I have an equation like this, and again, if I subtracted 11, I'd have a hard time figuring out two numbers that multiply to be 11 and subtract to be 8, because there aren't any rational ones. But I can use this process of completing the square to get my answer. So I've got a couple of things here. What we're going to do is we're going to rewrite these with some space. And that means, what's wrong with my marker? That's a blooper reel. X squared minus 8x plus some space equals 11 plus some space. So I'm going to add something to here and then keep it balanced by adding something to the other side. What am I going to add right here? Well, whatever completes the square. What's half of negative 8? Negative 4. Squared. That's 16. So I'm going to add a 16 here and a 16 to the other side. And now this thing factors, just like it did in the previous slide. This becomes x, this becomes 4, same middle sign, squared. And this over here becomes 27. So I've filled that space in, and now I've completed the square. Well, look, I've got something squared, a single occurrence of x. Something squared equals 27. Can I square root both sides? You betcha. And that gives me x minus 4 equals plus or minus the square root of 27. Adding 4 to both sides, and I get x equals 4 plus or minus the square root of 27. Neat. So that's how that works. That one over there works in the same way. There's another thing with the vertex form. I think I'll let that show up on the answer key notes. But if you have any questions with this, feel free to send me an email.